Alright, let's go. Number 10. The Sailing Stones of Death Valley. In California's Racetrack Playa, a flat, cracked lakebed at the heart of Death Valley National Park, something impossible has been happening for thousands of years. Rocks, some weighing as much as 320 kilograms, move. They cross the desert floor on their own, leaving long, grooved trails pressed into the mud behind them, as if dragged by invisible hands. When geologist Jim McAllister first formally documented the phenomenon in the late 1940s, he had no explanation. Neither did anyone who came after him for the next 6 decades. The Racetrack Playa sits at an elevation of roughly 1,130 meters above sea level, ringed by mountains that shed boulders onto its surface over millennia. The lakebed itself is almost perfectly flat, a geological anomaly in its own right, and for most of the year it is completely dry. The rocks should stay exactly where they land. That is what geology predicts. That is what common sense demands. But the trails tell a different story. Some extend for 250 meters or more. Others curve gracefully, as if the rock changed its mind mid-journey. Several rocks have moved in parallel, tracing identical paths across the playa simultaneously, which suggests a shared mechanism, yet others nearby haven't moved at all. Some trails intersect, some double back. A few simply stop, the rock sitting at the end of its groove with no apparent reason to have started moving in the first place. In 2014, geologist Richard Norris of the Scripps Institution of Oceanography finally caught the rocks in motion using GPS trackers and time-lapse cameras. His team discovered that a precise combination of conditions, a thin sheet of ice forming overnight, then fracturing in the morning sun, pushed by winds as light as a gentle breeze, could slide the rocks across the wet mud beneath at speeds of 2 to 5 meters per minute. It was a satisfying answer. Almost. The mechanism explains some of the trails. It doesn't explain the ones that change direction sharply, or the rocks that moved during periods when the required conditions weren't present, or the oldest, deepest trails carved long before any instrument existed to record what the weather was doing. The rocks have been moving since long before humans arrived to watch them, and what drove the strangest journeys across this ancient lakebed remains, stubbornly, unknown. Number 9. The Richet Structure. Seen from the window of the International Space Station, the Sahara Desert contains something that looks less like geology and more like a target drawn on the Earth by a cosmic hand. A near-perfect blue and white bullseye 50 kilometers across sits in the western reaches of Mauritania, so geometrically precise and so visually distinct that early NASA astronauts used it as a navigation landmark during orbital passes. They called it the Eye of the Sahara. On the ground, walking through it, you would notice nothing unusual. The scale defeats the eye. Only from above does the strangeness become undeniable. The structure, formerly known as the Richet Structure, was initially interpreted as a meteor impact site. The circularity, the scale, the way the rings of rock alternate in composition and resistance, all of it pointed toward a catastrophic collision. Impact craters are common on Earth's surface, and the Richet seemed to fit the profile perfectly. Geologists expected to find shattered rock, shocked quartz, and impact ejecta, the geological fingerprints that high-velocity collisions always leave behind. They found none of it. No impact debris, no shocked minerals, no evidence whatsoever of a collision. What they found instead were concentric rings of quartzite and dolomite, folded and domed upward from below, suggesting that the structure formed not from something hitting the surface, but from something pushing up through it. A geological dome, eroded over millions of years into its current circular shape. The rock at the center is among the oldest exposed in the region, dating back hundreds of millions of years. The official classification is a pericline, a symmetrical dome-shaped fold in the rock that erosion has worn down into a bowl. It is a plausible explanation, and most geologists accept it. But the near-perfect circularity remains deeply unusual. Erosion is a chaotic process, shaped by wind direction, rainfall, rock hardness variations, and the slow chaos of plate movement. It does not typically produce structures this symmetrical. Similar processes operating on similar rock types elsewhere in the world have never produced anything remotely resembling the Richet. Every explanation for this structure requires conditions so specific they have never been observed, producing anything like it anywhere else on Earth. which means either our models of how erosion and geological doming interact are missing something fundamental, or this place is genuinely, irreducibly unique in ways that science has not yet managed to articulate. Number 8. The mobile cave ecosystem. In 1986, workers drilling a geothermal borehole near the city of Mangalia on Romania's Black Sea coast broke through into a sealed underground chamber. They had not been looking for it. No maps showed it. No geological survey had predicted it. Biologist Christian Lascu descended into the darkness to assess what they had found, and what he encountered rewrote the boundaries of what science believed life required in order to exist. The cave had been completely sealed from the surface world for an estimated 5.5 million years. It was not empty. Life requires, at minimum, sunlight or a connection to something that sunlight has touched. That was the assumption. Photosynthesis drives the base of every food chain on Earth. Energy from the sun, captured by plants, passed upward through every living system we had ever studied. Movile Cave has no sunlight. It has no plants. It has no connection to any surface ecosystem. Its oxygen levels hover around 10%, less than half the atmospheric concentration above ground. Its carbon dioxide concentrations run 50 to 80 times higher than normal air. By every standard model of ecology, it should be sterile. Instead, it contains a thriving, layered ecosystem. More than 30 unique species have been cataloged inside Movile Cave: spiders, leeches, water scorpions, pseudoscorpions, isopods, none of them found anywhere else on Earth. They evolved in total darkness, in toxic air, in complete isolation, over millions of years. The entire food chain rests not on photosynthesis, but on chemosynthesis. Microbes that extract energy from the hydrogen sulfide dissolved in the cave's water, producing organic matter from chemistry alone without a single photon of light. The discovery forced a fundamental revision of astrobiology, the science of where life might exist beyond Earth. If a stable, complex, multi-species ecosystem can operate entirely on chemical energy in conditions toxic to virtually every organism we had ever studied, then the constraints on life are far looser than science had assumed. Europa, Jupiter's ice-covered moon, has a liquid ocean beneath its frozen surface, warmed by tidal forces and likely rich in chemical gradients not unlike those in Movile's water. Enceladus, Saturn's moon, vents hydrogen-rich plumes into space from a similar subsurface ocean. What Movile Cave demonstrated is that life doesn't need the sun. It needs chemistry, liquid water, and time. Earth may contain dozens of similar sealed ecosystems that no drill has yet reached, and if sealed caves on this planet can sustain independent biospheres for millions of years, the question of whether similar worlds exist elsewhere in the solar system has moved from speculation to something far more serious. Number 7. The Siberian methane craters. In the summer of 2014, a helicopter pilot surveying the Yamal Peninsula in northwestern Siberia noticed something on the landscape that had not been there the previous year. A perfectly cylindrical hole had opened in the tundra, approximately 30 meters wide, deep enough that the bottom was invisible from the air, its edges clean and steep as if something had punched through the ground from below. Local reindeer herders reported hearing an explosion before it appeared. Russian scientists scrambled to investigate. By the time they reached it, a second crater had opened, then a third. The Yamal Peninsula sits atop one of the largest deposits of permafrost on Earth, ground that has been continuously frozen for thousands of years, locking vast quantities of organic material and methane gas in a deep frozen suspension. As global temperatures have increased, that permafrost has begun to thaw. Scientists had expected this to release methane gradually, a slow seepage that climate models had been trying to quantify for decades. What no model had predicted was this: sudden, explosive decompression events that blast holes in the landscape without warning. Evgeny Chuvalin of the Skolkovo Institute of Science and Technology led early analysis of the craters and confirmed the mechanism. As permafrost thaws, methane hydrates, ice-like structures that trap gas in a solid lattice, destabilize and release their gas. The gas accumulates in pockets beneath the surface, building pressure until the ground above ruptures. Inside the first Yamal crater, researchers measured methane concentrations reported at tens of thousands of times normal atmospheric levels. The geometry of the holes, their near-perfect cylindrical shape, suggests the explosions are more focused and more violent than anyone anticipated. More than 20 confirmed craters have now been documented across the Yamal and Gaidan peninsulas, with new ones continuing to appear. Vladimir Romanovsky of the University of Alaska Fairbanks has tracked permafrost temperatures across the Siberian Arctic for decades, and his data shows warming accelerating beyond the projections of every model his team has built. The rate at which new craters are forming is outpacing scientific prediction. The craters themselves are not the deepest mystery. What scientists cannot calculate is what lies beneath them. The total extent of the pressurized methane system, how much gas it contains, and how much instability has already accumulated in the frozen ground without yet finding a way out. Each new hole is not just a geological event, it is a pressure gauge reading from a system whose total size remains unknown. Number 6. The Taos Hum. Sometime in the early 1990s, residents in and around Taos, New Mexico began reporting a sound that wouldn't stop. Not a ringing, not a rumble from passing traffic. A persistent low-frequency drone, described consistently as resembling a diesel engine idling just out of sight, that permeated their homes day and night, disrupting sleep, causing headaches, and in some cases, driving people to the edge of psychological breakdown. The complaints reached the United States Congress. In 1993, a formal federal investigation was commissioned. 4 of the country's most prestigious scientific institutions were brought in to find the source. The investigation team was not composed of amateurs. Researchers from the University of New Mexico, Sandia National Laboratories, Los Alamos National Laboratory, and the Phillips Air Force Research Laboratory deployed instruments across the region, measuring acoustic signals, electromagnetic frequencies, seismic activity, and industrial noise output. They interviewed hundreds of residents. They mapped the geographic distribution of who could hear the sound and who could not. They had the full resources of the federal government and the analytical power of institutions that design nuclear weapons and spacecraft. What makes the Taos Hum genuinely disturbing is not just that the source was never found, it is who can hear it. Approximately 2% of the local population perceives the sound. Not 2% of a sensitive subgroup. Not 2% of people with diagnosed hearing conditions. 2% of a random cross-section of the community. The rest hear nothing. Standard recording equipment detects nothing. The hum exists verifiably for those who hear it. It has measurable effects on their health and quality of life, but it leaves no trace on any instrument science has deployed to find it. The 1997 official report concluded without qualification that the source of the Taos Hum could not be identified. Similar unexplained hums have since been documented in Bristol, England, and Largs, Scotland, each with the same characteristics: low frequency, selective audibility, no detectable source. The Bristol Hum investigation produced identical results: acknowledged, investigated, unresolved. If 4 federal research laboratories with unlimited access to a region cannot find the source of a sound that hundreds of people hear every day of their lives, it forces an uncomfortable question about the boundary between what is real and what our instruments are capable of detecting, and whether those two things are as synonymous as science has always assumed. Number 5. The Devil's Kettle Waterfall. In the forests of Cook County, Minnesota, inside the entirely unremarkable Judge C.R. Magny State Park, the Brule River flows northeast toward Lake Superior. Halfway through the park, the river encounters a rock formation that splits it cleanly in 2. The right fork drops over a standard waterfall and continues downhill, rejoining the normal geography of the region. The left fork drops into a circular pothole in the rock, roughly 1.5 meters across, and disappears. Hundreds of thousands of liters of water per day pour into that hole. None of it has ever been found again. This is not a remote or inaccessible location. The Devil's Kettle, as the pothole is known, sits along a well-maintained trail in a state park that receives thousands of visitors annually. Geologists have studied it for decades. The conventional expectation was straightforward. Underground waterways always emerge somewhere. Water follows gravity, finds the path of least resistance, and surfaces eventually in a spring, a seep, a connection to a larger body of water. The geology of the area, composed of rhyolite bedrock, should be relatively impermeable. There should be a clear outlet. There should be an obvious answer. Researchers conducted dye trace studies, pouring colored dye into the kettle and monitoring every downstream water body for its appearance. They dropped ping pong balls, tracking devices, and floatable markers. Nothing ever emerged. No dye appeared in Lake Superior. No markers turned up in adjacent streams or springs. The water went in and, by every method available to science, simply ceased to exist downstream. In 2017, Jeff Thole of the Minnesota Department of Natural Resources revisited the problem using more precise flow measurements. His team concluded that earlier estimates of the volume of water entering the kettle had been overstated, that the actual flow was lower than previously calculated, making an underground channel more hydrologically plausible. It was a careful, methodical recalibration. It did not, however, identify where the water goes. The Devil's Kettle was not solved in 2017. The mathematics were adjusted. The mystery was made slightly smaller. But the water is still flowing into a hole in a state park in Minnesota, and no instrument, no dye, no tracking device deployed in decades of investigation has ever established where it surfaces. For a phenomenon this mundane, in a location this accessible, that absence of an answer is more unsettling than any exotic geological rarity could be. Number 4. The Grand Canyon's missing billion years. Stand at the rim of the Grand Canyon in Arizona, and you are looking at 1.7 billion years of Earth's history exposed in layered rock like the pages of a book left open in the desert sun. Geologists can read those layers: limestone laid down by ancient seas, sandstone from vanished river deltas, shale compressed from prehistoric mud, and construct a timeline of this planet's past with extraordinary precision. But at one specific horizon, deep in the canyon walls, the book has a page torn out. Not a few pages, not a chapter. More than a billion years of Earth's history simply does not exist. The boundary is called the Great Unconformity, first described by explorer and geologist John Wesley Powell during his 1869 expedition down the Colorado River. Powell noticed that the rocks directly above and below this surface were separated by an enormous gap in time. Rock that formed 1.7 billion years ago, sitting directly on top of rock that formed roughly 520 million years ago. Between them, approximately 1.2 billion years of geological record is absent. No sediment, no fossils, no chemical traces. An era longer than the entire span of complex animal life on this planet, erased without apparent remainder. What makes the Great Unconformity so unsettling is not just the size of the gap, but the nature of the surface that marks it. It is remarkably flat, unnervingly flat. Normal erosion, the process that geologists initially assumed must have stripped away those missing layers, is chaotic and irregular. It leaves ragged surfaces, differential remnants, pockets of partially eroded material. The unconformity surface of the Grand Canyon is smooth and horizontal in a way that suggests something far more systematic and total than ordinary weathering. In 2019, a study published in Nature Geoscience led by Bara Peak of the University of Colorado Boulder proposed that the missing rock was stripped away during the Cryogenian period, the era of snowball Earth, when glaciers may have covered the planet from pole to pole, and the grinding advance of continental ice sheets eroded the surface down to bedrock on a global scale. It is a compelling hypothesis, and it aligns with evidence from other sites. The Great Unconformity appears not only in Arizona, but in the Scottish Highlands, in Scandinavia, and at multiple locations across North America, all at roughly the same geological moment. But a global hypothesis of this magnitude requires global evidence, and the snowball Earth model still struggles to account for both the extraordinary flatness of the surface and its simultaneous appearance across continents separated by thousands of kilometers. Whatever happened during those missing billion years was thorough enough to leave no recoverable record of its own occurrence. How do you begin to explain an absence that large? Number 3, the Yonaguni Monument. In 1987, Kihachiro Aratake, a diving instructor exploring the waters off Yonaguni Island, Japan's westernmost inhabited point in the East China Sea, descended to a depth of roughly 25 meters and found himself facing something that stopped him completely. Flat terraces, right angles, parallel walls rising in stepped formations from the seafloor, what appeared to be staircases, an enormous stone structure, approximately 150 meters long, 40 meters wide, and 27 meters tall, carved from a single mass of solid rock. It covered an area roughly the size of 2 football fields, and nothing in the surrounding seabed looked anything like it. The immediate question was the same one it always is when humans encounter geometry in nature. Did something make this, or did nature? The rock itself, mudstone and sandstone consistent with the Ryukyu Island chain geology, is known to fracture along parallel planes and right angles under certain stress conditions. Sandstone, in particular, can produce remarkably regular shapes when tectonic forces and erosion act on it over geological timescales. The argument for a natural origin was not without foundation, but Professor Masaki Kimura of the University of the Ryukyu spent years diving the structure and cataloged features that he argued went far beyond what natural fracturing could produce. Tool marks on certain surfaces, what appeared to be a drainage channel running along the base of one of the main terraces, and a possible carved pathway connecting different levels of the formation. His interpretation was that the Yonaguni Monument was a man-made structure constructed by a civilization that occupied this coastline before sea levels rose at the end of the last ice age, approximately 10,000 to 12,000 years ago. At that time, the site would have been dry land. Professor Robert Schoch of Boston University, a geologist who has studied natural rock formations worldwide, reached the opposite conclusion. In Schoch's assessment, every feature Kimura attributed to human construction could be explained by the known fracturing behavior of sandstone under geological stress. The apparent staircases, the right angles, the flat terraces, all of it consistent, in his view, with natural processes. Two credentialed scientists, both with direct experience of the site, in direct and unresolved contradiction. The debate between Kimura and Schoch has never been settled. No excavation has been conducted. No definitive physical evidence of tool use has been recovered and independently verified. The Yonaguni Monument sits at the bottom of the East China Sea, 25 meters down, maintaining its silence. If it is man-made, it predates the pyramids of Egypt by thousands of years and demands a fundamental revision of what we know about early human civilization in the Pacific. But if it is natural, then nature, working alone with stress fractures and seawater, built something that looks more deliberately constructed than most buildings ever raised by human hands. Number 2, the Deccan Traps and the Chicxulub timing problem. 66 million years ago, an asteroid approximately 10 to 15 kilometers in diameter struck what is now the Yucatan Peninsula of Mexico at a speed of roughly 20 kilometers per second, releasing energy equivalent to billions of nuclear weapons and ending the reign of the non-avian dinosaurs. The Chicxulub impact is one of the most studied events in Earth's history, and its role in the mass extinction that followed is beyond serious scientific dispute. But there is a problem, a deep, unresolved, and profoundly unsettling problem that emerged when geologists began looking more carefully at what was happening on the other side of the planet at exactly the same moment. The Deccan Traps are a vast volcanic province covering much of what is now central India, the solidified remnants of one of the largest volcanic episodes in Earth's history, in which enormous volumes of lava flooded across the landscape over a period of hundreds of thousands of years. The Deccan eruptions were already underway before the Chicxulub asteroid struck. That much was established. What was not established, and what a 2015 study published in Science by Paul Wren of the Berkeley Geochronology Center revealed, was the precise timing of what happened next. The Deccan eruptions dramatically intensified immediately after the Chicxulub impact, not gradually, not over millions of years. Immediately, in geological terms, within tens of thousands of years of the asteroid strike, which is essentially simultaneous. Wren's team, using high-precision argon dating of Deccan lava flows, found that the eruption rate roughly doubled in the period following the impact. Two world-ending events on opposite sides of the planet, causally connected across 12,000 kilometers of rock. The mechanism proposed is seismic. An impact of Chicxulub's magnitude would have sent seismic waves of extraordinary power reverberating through the entire planet. Waves strong enough, some researchers argue, to destabilize magma chambers on the far side of the Earth and trigger or accelerate volcanic activity that was already building. Mark Richards of the University of California, Berkeley published supporting analysis in 2015 modeling how the impact's seismic energy could have focused at the antipodal point, the location on Earth's surface directly opposite the impact site, with sufficient intensity to rupture the Deccan system. Not all geologists accept the causal link. Some maintain the timing is coincidental, that two independent catastrophic events simply happen to overlap within a geological eye blink, and that the apparent connection is a statistical artifact of the resolution limits of radiometric dating. The debate remains genuinely unresolved in the scientific literature. But if the connection is real, if a single asteroid impact sent shockwaves through the entire planet and triggered the largest volcanic episode in tens of millions of years on the opposite side of the globe, then the stability of Earth's interior is far more sensitive to external perturbation than any current model accounts for. And the question of what else might be capable of disturbing it deserves to be asked with considerably more urgency than it has been. Number 1, the granite problem. Granite is everywhere. It is the foundation beneath every major city on Earth, the bedrock of every continent, the raw material from which mountain ranges are built, and from which ancient civilizations cut their most enduring monuments. The pyramids of Egypt, the temples of antiquity, the paving stones beneath the feet of billions of people, granite. It constitutes the overwhelming majority of Earth's continental crust. It is the most studied rock in the history of geology. Scientists have been analyzing it, classifying it, debating its origins, and publishing papers about its formation for more than 2 centuries. And yet, despite all of that, geologists still do not fully agree on how granite forms. The deeper they look, the less certain the answer becomes. The standard explanation, dominant since the work of Norman Levi Bowen in the 1920s, holds that granite crystallizes from slowly cooling magma deep within the Earth's crust, molten rock generated in the mantle, or by the partial melting of existing crustal material that rises, cools, and solidifies over millions of years into the coarse-grained feldspar-rich rock we recognize. It is a clean, elegant, well-supported model. Bowen's experimental work on the crystallization sequences of silicate minerals remains foundational geology. For much of the 20th century, the magmatic origin of granite was treated as settled. Then came the volume problem. The amount of granite in Earth's continental crust, its sheer total mass, requires, under Bowen's model, a quantity of source magma that the mantle cannot plausibly have produced through the mechanisms we understand. The numbers don't balance. Granite is too abundant for the magmatic model to fully account for it. In the mid-20th century, geologist Herbert Harold Reed proposed what became known as the transformist hypothesis, that some granite forms not from cooling magma, but through a solid-state process called granitization, in which existing rock is chemically transformed into granite by the migration of fluids through the crust without ever becoming fully molten. Reed's famous dictum, "The more you study granite, the more you become a transformist," became one of geology's most enduring provocations. The debate between magmatists and transformists consumed much of 20th century petrology. It was never cleanly resolved. The magmatic origin of most granites is now broadly accepted, but the transformist position was never fully disproven, and the volume problem was never fully solved. Modern high-precision geochemical analysis has added further complications. The water problem, in which the mineral assemblages found in granite require enormous quantities of water during formation at depths where free water should not be present in those quantities. The heat problem, in which the temperatures required for crustal melting at depth are higher than the geothermal gradients of stable continental regions should permit. And the contamination problem, in which the chemical signatures of granites frequently reflect mixing between multiple source materials in proportions and configurations that no single formation model cleanly predicts. A 2021 study in the journal Nature by researchers including Craig Story of the University of Portsmouth examined granite formation across multiple geological settings and found evidence that multiple distinct processes were operating simultaneously in different regions. That granite is not a single phenomenon with a single origin, but a category of outcomes produced by fundamentally different mechanisms depending on the local conditions. The most abundant rock on the surface of the Earth, it turns out, may not have a single answer to the question of how it came to be. We have built civilizations on granite for 10,000 years. We have quarried it, studied it, held it in our hands, and placed it at the foundation of everything we call permanent. And at the deepest level of understanding, the rock beneath our feet remains an open question, which means that the most profound geological mystery on this planet is not hidden in a remote desert, sealed in a cave, or buried beneath a frozen sea. It is directly underneath you right now, and we still don't fully know how it got there. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.